All right, let's talk about what this problem is. It's problem number 13. And it looks like it took a really tough integration to me. Looking at it and say, where do you start? Let's write this down over here. It's something that looks really so bizarre. It's almost like it's almost impossible to do. And I'm just simply copying what I'm seeing over here. And then X, and then they put this dot, dot, dot. And what they're saying over there is that you have some understanding that this goes on forever. And they go on to say, furthermore, that the X is greater than or equal to 0. All right? So, looking at it, someone says, where do you start? I can't do that integration as it stands. I just don't recognize it. And a U substitution is not going to work out. So one thing I would do is just write down, I'm going to look at the integrand, and this is the integrand, and I'm going to try to simplify the integrand, all right? And looking at it, it's recursive. So I'm going to say, let me just make it as simple as possible. All right, y equals the integrand. And that's what this is over here. Let me write this down, x plus, I put a hat on that. I got to get rid of that because it goes on forever, by the way. And let me just extend that and extend this guy. These go on forever and ever and ever and ever. It's going to be x plus, root x plus dot, dot, dot. I think you get the idea. What I'm going to do is I'm going to square both sides and try to get rid of, at least one of the roots. And what do you get over here? Y squared. Oh, by the way, y is greater than or equal to 0. All right? So let me keep doing that. Y squared gives you what? It gives you x plus, let's write this down. What do you get over here? X plus, wow, look at that. It looks like it just repeats itself over and over again. So I'm going to say over here, I'm looking at this and I'm starting to realize that this guy here looks just like this guy here. So I'll write that down now. So y squared looks like x plus y. All right? Then the question becomes is, can I figure out what the integrand is? And the integrand, again, is y. So I'm going to look at this, and it's really quadratic in form. I'll write down y squared. Let's see, minus y minus x equals 0. And let's see what you get there. And I'm going to try to figure that out. And I'm going to write this as y squared minus y is equal to x. And I'm going to complete the square on it. How do you do that? Take half the coefficient of this guy, which is minus 1. That's going to be minus 1/2, and square it. That's a quarter. I'm going to add a quarter to both sides. And what do you get there? You get y minus 1/2 quantity squared. That's the perfect square, equals x plus 1/4. You could also use quadratic form, by the way, but computing square is not a bad idea. So what do you get over here? Y minus 1/2 equals plus or minus the square root of x plus 1/4. All right? Let me keep rewriting it. And as I do that, I'm not going to say it's the easiest thing in the world to do, but y equals, it's going to be 1/2, and then I get plus or minus the square root of x plus 1/4. I just don't like the way that looks. I also got to figure this out. It's two different things. How could it possibly be? So let's keep writing it over here. I'm going to write y is, I'm going to put a 2 here, a common denominator. And before I do that, I want to get rid of this radicand. That means x plus 1/4. I'm going to write it a little bit differently. I'm going to write it as 2x. I'm going to put this over here. Not 2x, 4x, sorry. 4x plus 1 over 4. So now I kind of see it. It's going to be 1 plus or minus, and that's going to be 4x plus 1. And again, as it stands to look at that, it looks bizarre. I mean, what do you do with this? I got two different answers over here. But again, I want to go back to the beginning. And one thing I know about, the x is a positive number. It's greater than or equal, I should say, a non-negative number, and y has got to be a non-negative number. So looking at this over here, I'm going to kind of reason through this. Y equals, and that's what I want to figure out, it equals 1 plus. Now, why is that? I can't, like if x is greater than or equal to 0, I can't allow this thing to go negative, by the way, y. So it's got to be the plus part, because otherwise this thing would produce a negative number. So let's write this over here. 4x plus 1 over 2. So what I did was I took that in the original integration now, and I got a simpler problem. It still may be impossible, by the way, but that integrand now, which is y, is really just this over here. all right? So I'm going to see if I can do that. I'm looking at it. I'm wondering what to do about that, and can I do that integration? I think I can. And the first thing I'm going to do is just pull it out, that half, and then I get, 1 plus the root 4x plus 1 dx. I'm trying to figure out if I can do that. Certainly the first term. And looking at the second term, I think I know the antiderivative of that. I'm going to basically do it in steps here. So I'm going to say, it's 1/2 1 dx plus 1/2 root 4x plus 1 dx. And let's just go through it one step at a time. What do you get over here? You get 1/2 x. I'm not going to put the constant integration down until I'm all done with it. All right. Now, what I'm going to do over the second integration, I'm going to make a u substitution. I'm going to say u equals 4x plus 1. du would be 4 dx. All right. I'm going to write that down now. I'll put a 4 here, and I'll put a 4 over there. All right. What do you get? You get plus 1/8. I'm going to put a star here. I see the 4 dx, which is just du. And what's 4x plus 1? It's just u, so I get u to the 1/2 power. Well, I'm ready to integrate that guy now. What do you get? 1/2 x plus 1/8. This is going to be u. I'm going to increase the exponent by 1. That's 3 over 2. Divide by 3 over 2 is like multiplying by 2/3. And there will be a constant of integration. All right, we'll figure that out in a moment. What do you get over here? 1/2 x plus, well, I'm looking at this thing, I'm going to reduce the fraction. 2 goes in 4 times, and 4 times 3 is 12. And u to the 3s, it's really going to be u root u. What was u? It's 4x plus 1. So it's going to be 4x plus 1. And again, it's 3s, so it's 1 and a half. And then the half is going to be the root of it, 4x plus 1. I go back to x's, I got this over here. And I think I'm done. All right, now certainly someone says, you're really done. Well, you look at the key. The work is in the key, by the way, but I want to look at the answer in the key. And what's the answer in the key? Well, you look at it, and I do see this. I see this in the key. I'm looking at the end of the key. I'm not looking at the work. And I got this over here, and we're good to go. That was a tough question, though. All right, what's tough about it? The integrand was tough. I simplified the integrand. I wrote it in a different form, and we're done. All right, thank you.